This is Channel Kaushik again, and I'm recording this video for chemical process safety class final project. And the next VBA that I'll be discussing would be the relief valve sizing VBA. And let me go ahead and open it. So this is the VBA in which we have three cases of sizing the relief valve. So the icons that you can see over here are the three icons which my click would start these three cases of designing the relief valve. The first case is conventional spring operated relief in liquid or vapor gas service. The second case is balanced bellows spring operated relief in liquid or gas service. And the third case is flow of liquid through a hole in a tank, which is a source model. So as you can see, with the help of VBA, it's quite easy and it's flexible to enter all the data into the VBA, and then I can run this to get the result at the end. So as you can see over here, the results are already here. For the third case, the number of the liquid spill in gallons and the length of time required for the liquid to get spilled. So let's go ahead and start the first case. If I click it over here, it's gonna start the first case. So if I click it away, once again it's gonna ask for my name. So I'm gonna enter my name. So it's gonna pop up a message which says hello Chandra. And then it's gonna ask the volumetric flow through the relief in gallons per minute. So I'm gonna enter 200, and then it's gonna ask the discharge coefficient. So I'm gonna enter 0.61, and the specific gravity I'm gonna enter 1, which is for war, and the delta P in pounds per range. Let's say I'll say 200. And formula for the relief area, there's already a default formula over here, so I don't need to enter it again and again. So this was a part where in VBA programming I have already entered the formula, so I don't need to enter it again. I just can cross check it. So everything looks fine. So I'm gonna click OK, and then there pops up formula for diameter. So there is also a default formula for diameter um, of the relief area. So I'm gonna click OK, and then in the background, as you can see, the heading has already changed. It says case 1. Since I clicked this thing, I got all the input from the user, and I got the computed relief area in inch square and the calculated diameter. So as you can see, I did nothing. I just entered the values, and then I got the results. So it's quite flexible, and it's also it's not at all time consuming, and it's gonna save a lot of time. So it's a really helpful tool. And let's go ahead and check case 2, which is a balanced bellows spring operated relief. Which gonna use number of graphs. So let's go ahead and start with the case 2. Let me go ahead and enter my name once again. Alright, and then it's gonna pop a message again. Volumetric flow, I'm gonna enter 200, and then discharge coefficient 0.61, and the specific gravity 1, and the set pressure 200. Let's say, just for the sake of running the program, now the back pressure of 20. I'm gonna enter the value of 1 in kb, kb and kp. If I want to know the actual values of the value of kb, kv, and kp, I can click all these three buttons before the start of the program. So I can know the value of kb, kv, and kp beforehand, and then I can enter the values over here. For the sake of simplicity, I'm gonna enter 1, 1, 1 in each of them, and then there's a default formula for relief area, which I'm gonna click OK. Since I know that it's fine, I don't need to modify it. And then there's a formula for diameter, so I'm gonna click OK. So I have all of this value over here, and the results are available over here. So there might be some problem with the relief area, which I'm gonna fix later on. Let me go ahead and quickly complete the case 3. So it's gonna ask for my name. I did enter name, so it's gonna pop our message, hello Chandra. Now this is a source model, the case 3, which says flow of liquid through a hole in a tank. So I'm gonna enter each and every values over here. Let's say the tank is of 20-foot height, and the density of the liquid is, let's say, 600, and enter the diameter of the tank. Let's say diameter of the tank is 15, and diameter of the hole is 2, and the gauge pressure is in Albion perfect is less for the sake of completing the program, let's say 50. And formula for the leak area by default formula is given, so we'll click OK. Again OK. Formula for liquid spill, all these default formula I have inserted all of this formula inside the coding of VBA, so I need to if I want I can check it, but for my case I do know that it's correct, so I'm gonna just click OK. So after completing everything, there's a message which pops up. This message pops up because there's a condition I have put inside the VB programming. If the time which is calculated, if it's less than 50 minutes, 50 minutes, then there seems to be more than adequate time to stop the leak or to invoke an emergency procedure to reduce the impact of the leak. So we do have enough time to mitigate the leak. So I'm gonna click OK. And so these are the three cases. So as you can see, when I've clicked the case 3, it's gonna pop up over here that it's a flow of liquids through a hole in a tank, and everything gets changed, and the results are right over here. And let's quickly go ahead and look through each and every programming. um, for the three cases I have three different modules, and I don't have any yeah, I do have three forms over here. These are for the graphs to pop up, graph 1, 2 and 3 for the KP, KB and KB. Let's go ahead and see what are the codes I have written for the case 1. Alright, so here are the codes, and the first code, as you can see, I've defined each and every variables right over here, and then there's a message which says please type in your name, and there's a message which says, I mean, if I don't enter any name, it's gonna say you didn't enter any name. Otherwise it's gonna, if I enter a name, it's gonna say hello and my name. So all these ranges value I've inserted with these values. If I run the program, all these cells is gonna have all these values, as we have seen in the Excel file. And then this is the input commands that I have written in order to get everything from the user. So this and here's the formula. This formula is for the relief area. It's a simple Excel formula which I have inserted over here. So once I insert all of this formula, I don't have to do anything. I just want to verify if my formula is right, and that's it. And I get the results. And here are the other programming codes that I've entered in order to get the right kind of color that I want over here in the Excel file. So I can modify it anytime. I've seen, I learned all of these things by watching the VBA videos that's available on YouTube. So this is the case for these are the codings for the case 1, and then let's move to the case 2. um, Most of the things here are the same. um, just the formula for calculating the relief area changes, and everything is almost the same for the balance values. um, so yep, so that's it. And the case 3, the case 3 the, the starting point of the case 3 is almost the same. And the only difference here is that here we have to calculate the area of the leak, area of the tank, liquid spill, time to liquid out, and here is my if statement. If says if the time is less than 50, um, actually this has to be greater than, which sounds more logical. So yeah, I can correct it anytime. Yeah, it happens when you make any mistake in the VB, but it's like user friendly, you can correct it anytime. So I'm gonna save it, and then I'm gonna reset it and then I can run it again. So if the value of the time, if it's greater than 50, I mean if the leak is too slow, the time for the liquid to spill out is greater than 15 minutes, then this appears to be more than accurate time to stop the leak. Otherwise there is insufficient time to mitigate the threat, and it's gonna pop up my name. And here is the coding for all the colors that I can have. I can change it anytime according to my needs. So these are all the VBA codes that me and my team has prepared. So that's it. And so here we are. It's a user friendly tool. and we just have to enter the values, and these are the graphs that we can click anytime to get the value to get the graph to calculate the values of kb, kp, and kb. So that's it for this video.